Welcome to Lesson 17, Learn C Programming on the Raspberry Pi. Well, last lesson we did quite an elaborate program that allows two people to play tic-tac-toe on the Pi and have their input displayed on 9 LEDs. So we were using two color LEDs, or some people call them red-green LEDs. Anyway, here's the code that we came up with last day. You can see that we used 18 GPIO pins because each LED requires 2 pins plus a ground. And then of course the code we initialized everything here, basically turning off all 9 LEDs, and then we just started to play the game here in this, using this while loop all the way down to here. And so if it was a red's move, then the red could turn on a light from 0 to 8, which there's 9 lights. If it was green's move, then green could turn on a light from 0 to 8, one of the 9 lights. And at the end of every move, we switch players using this little if statement here. And then once we type in a number that's 9 or greater, then we just turn all the lights off here and we end. So that's just quickly going over the code we did last day. If you missed the last lesson, then you should by all means go over it again. And if there are some things you don't understand, well, then you should review it. I want to get back now to learning more about the C language. So I'm going to just kind of review just what we did so far, and maybe make those fonts just a little bit bigger. Maybe 16 here. Here and here, just to make it a little more readable. Okay, so just a review now about C, what we've been doing for the last 16 lessons. We learned that from the C library, we learned how to use 3 functions: printf, scanf, and string compare. We also learned that to include the library, the C library, we used the -LC, which I said was optional. We also learned from the math library how to use the power function and the square root function. And then from the wiring Pi library, we learned how to use these 4 functions: wiring Pi, setup GPIO, pin mode, digital write, delay. We also learned the importance of using these header files. We used 3 different header files so far: standard.io.h, string.h, and wiringpi.h. Remember, the string.h was used for the string compare function. Standard.io was used for scanf and printf, and wiringpi gave the definitions of these functions up here. We also learned how functions communicate. They use parameters or arguments to pass data between them. That's one way they can communicate. They can use the return statement to pass a value back to the calling function, or they can use global variables. We've also been in the C language. We learned a lot about the for loop, because I use that a lot. We occasionally use a while loop. I use an if statement, use a switch statement, use a return statement. Basically, that's all we learned up to this point. And for language operators, we learned that the ampersand is used in scanf function, means address of. The asterisk, we use that as a pointer to, but it also has a meaning in arithmetic as multiplication. We use the comparison operator to compare two values. Are they equal or not equal? And we use the assignment operator to assign, say, x equals 12. We're assigning 12 to the variable x. But we also use, and I'll add that in here, we also use the plus, which is the arithmetic addition operator. Of course, you'll see later on that there are dozens more operators. We'll get into them as we go through. Keep in mind that these lessons I'm putting together are intended to learn the actual C language fairly comprehensively, and also to learn about the Raspberry Pi, and also probably to learn a little bit of electronics. So I can easily see, and I think I've said this before, I can easily see this this course consisting of probably 100 or so lessons. Don't be fooled. You can't really learn C programming over the weekend. I know there are books that say learn C in 24 hours and things like that, but they're not really realistic. I think to become a competent C programmer would probably take 6 months or maybe more of a lot of work and a lot of practice. So don't be discouraged. Just keep on working on these lessons. We also talked about the C language data. We said there were float types, which are fractional numbers, like 3.1 or something like that. There are integers, which are whole numbers, like 5 or minus 10 or something like that. Characters, like letters, A, B, C, D, and we also played with some arrays. Arrays are just basically a collection of the same type. So you can have an array of characters, you can have an array of integers, an array of floats, but you can't mix. You can't have an array that contains some floats and some ints and some characters. I also put together a list here of C language terms that we've covered so far. What do we mean by compile? What's a library? What's meant by call by value? What are actual parameters versus formal parameters? What is a function prototype? What is meant by return value? What is a pointer? What is an address? What do we mean by local versus global scope? And I also mentioned a little bit about function coupling. So up to this lesson, these are terms that I've talked about. Again, if you haven't got a good feel for some of these terms, then Google is your friend. You should check it out. Get other people's definitions of these terms, and just become familiar with them. And lastly, some Linux commands that we use so far. The cat command to concatenate files, cd, change directory, gcc. Of course, this is the most important command because we are actually compiling our C program. Genie is our integrated development environment, basically the editor we use. LDD is to print the shared object dependencies, which tells us tells us which libraries our program is using. LS is to list the contents of a directory. MKDIR to make a directory. WC is is word count, which counts how many words or bytes or new lines are in a file. grep is used to search for strings in a file, and BC is our arbitrary position calculator, which I went over with you in a previous lesson where we discussed how to use BC to work with different bases, because we have discussed base 2, base 8, base 10, and base 16, which is hexadecimal. Okay, so that's our quick and dirty review. I'll just save that and we'll close it up. And I want to go into something a little more complicated today, a little more of a where we have to use our brains to figure things out. So I've decided we will write a little program to see if we can reverse the contents of an array. So let me just start it, and as we go through I'll explain it. Okay, so I'm just going to declare an array here of integers, and I will initialize it to the Fibonacci sequence. Now don't be afraid of that word. It's just Fibonacci was an Italian mathematician, lived I think in the 13th century. I'll talk about that later. 0, 1, 1, 2, 3, 5, 8, 13, 21. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 34. So what I'm going to do is I've got an array here of 10. In fact, what I'll do is I'll just put that as a define up here. Define n as 10. So I've got an array here, an array of 10 integers. So this first one is x at 0, this is x at 1, this is x at 2, x at 3, x at 4, x at 5, x at 6, x at 7, x at 8, x at 9. So there's 10 of them all together with indices 0 through 9. All right, what we want to do is we want to reverse this. In other words, I want to take this 34 and I want to put it down in the first position here. And I want to take the 21 and put it in the second position. And the 13, put it in the third position, and so on until I have the whole thing reversed. So let's do this with functions. We'll write our own functions for this. So first I need a print function to print out this array. So I'll just call it print. Print, and I'll say x. I want to print the array x, and the length of the array is going to be 10. Or actually, we just put in n. So this function is used just to print out the array. So what I'll do is I'll leave the rest blank for now as we're developing the code. But I'll put in this print function that I'm writing. Print. You notice it's not printf. I just call it print because it's my own function. Okay, the print function in C is called printf, formatted print. So int, let's say x, comma, int, just call it I. So this will be our print function. So I'll just put a for loop. Say, oops, I guess I need another variable here. int j for j equals 0, j is less than I, j plus plus, and I'll say print f %d and a space, comma, x bracket j. And I'll just print a new line at the end. Just a new line character, and so that is my print function. So in fact, what I could do right now is I could actually run this program, and it should just print out that integer array. So let's save it first. File, save as, and I will save it in, do I have lesson 17 here somewhere? I'll just save it and I'll call it rev.c. Okay, so why don't we just try it and see if it actually does something. And it was lesson 17. So there it is. So GCC minus OREV. Oops. Forgot to have a prototype for this. Remember that we're using the print function here, but the compiler doesn't know about it because it's declared down here below on line 11. So we have to put this prototype up here just to tell it, so that when the compiler, remember when the compiler is compiling, it's going line by line all the way down to the bottom. So when it gets to line 7, it has to know what that print is all about, and it does now because I put it in on line 3. I've given the prototype on line 3. Okay. So let's save that. We'll try it again. And we still have a problem. Print. Where do we have it? Line 7. I can't seem to see what the problem is with this. Oh, we don't put the brackets in. Sorry. We just give it the array, and n is the length of the array. Okay, let's try it once more. Sorry for the hiccup, but we'll just continue on. There we go, and now I can run it. Reverse. Okay, so you can see all it does right now is just print it out. There's nothing, doesn't do very much, just prints out the array. Okay, so now what we want to do is we want to, after we print it out, we want to write our own function called reverse. We would like to reverse x, which is n long. And after we reverse it, we want to print it again. Like so. So now we have to write the reverse function, our own reverse function. So let's do that. Now, what I'm going to do is I'll put this prototype at the top, which I'm going to need. Put that up here. Put a semicolon at the end there. Okay. So now we have this function here called reverse, where we want to reverse this array. A little bit tricky. A lot of ways to do it, but we'll try doing it without using a secondary array, just using this array X. So what we have to do is we have to say, we need another variable here. We have to do a for loop, int j, then we'll say for, say j equals 0, j is less than I/2, j plus plus. I'll explain this in a second here. I'm also going to need another variable. It's a temporary, like this. And so I'll say t equals x bracket j. So what I'm doing is I'm going to put a hold on the very first value. See, j starts off to be 0, j is 0, so x at 0 is going to be t. It's kind of a temporary placeholder, so it's going to hold that first value. Well, now that I've got that, I can now take the last value and put it into x at j. So I can say x bracket j is equal to x bracket, and it has to be I, which is 10, minus j. And then we can say x bracket I minus j, close bracket, is equal to t. Something like this. Something tells me this is not quite correct, but let's work it out. What I'd like to do here is, see, I have the array here, which there's 10 of them, 0 to 9. So I want to go from 0 to I over 2. Is 10 over 2 is 5. I want to go 0, 1, 2, 3, 4. Okay? Because that should be enough to reverse it. You only have to go halfway, because remember, if I'm taking this guy and putting it in here, and then I'm taking this guy and putting it in here, and then taking this one and putting it in here, and this one and putting it in here, and then this one and putting it in there, that's only basically, that's 1, 2, 3, 4, 5 exchanges. So that's why I'm going 0 to I over 2. 10 over 2 is 5. Pardon me. So 0 to 4 will give me 5. Well, you know what? Let's try it. No point in dilly-dallying. And what do we have? Well, you can see it's not quite right. We got 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. But our answer here, when we reverse it, is this last 0 was not in the right spot. Like that 0 should have been over here somewhere before this 1. So it seems like we reversed everything except the first 2. And I think the reason for that is because we might be able to just take this, because this I is 10, and it really should be the last value, which is a 9. So let's just try changing that. Say I is equal to I minus 1. So instead of 10, I will be 9. Because you see here, 10 minus 0 was 10, and that's incorrect. So let's save this guy by compiling him again, and we'll try it again. And this time it looks like, no, we don't have this. We don't have this one. So what could be the problem here? Well, rather than wasting time, let me just cat the solution I made. Tilde slash stuff C. So, less than or equal to. Okay, so less than or equal to, less than or equal to. Let's try that. So I'll save this guy, go over here, try it once more, and we got 0, 1, 1, 2, 3, 5, 8, 13, 21. So now it's reversed it. So yeah, it is kind of a brain teaser to figure this out, and usually when you're learning C in programming in school, the teacher will usually just give this to you. It's a very well-known algorithm. You don't have to go and reinvent the wheel. But basically this is just a little algorithm to reverse an array in place. Okay, so but we should test it again for different values. So let's try making the array to be 11, and we'll add another value in here. Did I say 34? What was the next value? 55? Yeah, because you get, how did I get to 55 here? I just added the previous 2. How did I get the 21? I just added the previous 2. This is just called the Fibonacci. F-I-B-O-N-A-C-C. Fibonacci sequence. Fibonacci, and you can look that up. Do a Google search on probably in Wikipedia, and look up this Italian mathematician from, I think, the 13th century, and you can learn all about Fibonacci numbers. I'm just using these numbers here as an example. You can use any numbers you want, and it should still reverse it. So anyway, let's go through this. I've changed the length of the array to 11. I've changed the length of the array to 11. Let's see if it still works. I've added in one extra number to make sure I've got 11 integers now. 0 to 10. So I'll save this guy. I'll clear this. And I'll compile again. And I will run it. And we'll see. We had 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. So it works. It works even if I have an odd number in the array or if I have an even number. So probably it's going to work for any numbers. I could put anything I want in here. I could put like a -2. If the first one I could put in 99. whatever I have in there, if I save it and I compile and I reverse it, it still seems to work. The 99 comes out at the end, and that's looking good. And that -2 here is -2 here. Okay. Okay, so this is just kind of increasing our knowledge of C, how to play with arrays more, and also how to make our own functions, and how to make prototypes, and how to use define for constants, basically for a constant. Okay. One quickie I could show you here is be careful when you make up names for your programs. Like here I call this program REV. Well, there happens to be a Linux command called REV. For example, if I echo John and I pipe it to REV, the REV will reverse the string. So I'll have whatever I echo. Echo is the bash command that's very similar to print. Just echo on the screen, hello world, echo hello world, and pipe it to REV, and it reverses it. Okay. So if I say echo 0 space 1 space 1 space 2 space 3 space 5 space 8 space 8 13, what's the next one in the Fibonacci sequence? 21, 34, 55. If I pipe that to reverse, you see how I get, well, it's reversed. It's reversed to 43, 34 to 43. It's reversed everything. So it looks kind of crazy. Anyway, we're getting off topic here, but I may as well go to, and I'll just add those into our lessons in our notes here, where we learned a couple of new Linux commands. I'll just put them back here. Echo is used to display on the screen, and REV is used to reverse a string. So you can just remember that. Play with these commands on Linux, just to improve your skills. Okay, so I think we're done with lesson 17. For homework, yeah, you could read up on Fibonacci. Probably look up other examples on how to reverse an array. Maybe you could hack this program, and instead of reversing an array of integers, reverse an array of characters. So it'll work like the REV command in Linux. So if you have characters like JOHN, it'll come out NHOJ. So you could kind of play with that to get to learn. Remember, the whole point of these lessons is for you to learn how to program in C, and you're never going to learn until you start doing it yourself. So it's important after every lesson to type in these examples I gave, try them out, hack them, try to get them to do something else, and make modifications, and you know, time goes by, and by the time we get to lesson 100, you'll be an excellent C programmer. Okay, thank you very much, and we will see you shortly for lesson 18.